Please welcome to the stage Dr. Tom Kasier.
Good morning. I'm Tom Kasier, a program manager at the Microsystems Technology Office, and today I'm going to talk to you about next generation communications. We all communicate. We heard about in some of the previous talks about communication. In fact, there's probably everyone in this room has something like this, a smartphone. And we don't just communicate by voice. We share data. We share video. There's probably people watching these presentations today on their smartphones. And we don't just communicate locally. With the advent of systems like the Starlink LEO system, we're communicating around the world. Especially, we can be connected anywhere on the face of the planet. Now, this is just people communicating. We have merging applications where we have things communicating. For example, for autonomous vehicles, we've envisioned the future of cars actually communicating with each other to overall improve highway safety and reduce congestion on highway. From a DoD perspective, we have the smart battlefield, where we have sensors distributed on the land, in space, in the air, all communicating to provide enhanced situational awareness for the warfighter. And of course, there's the exciting merging areas of virtual reality or augmented reality. And we heard a little bit yesterday about telemedicine, so that we can remotely have doctors operating on the injured warfighters from remote locations. Now, there's a lot of challenges with all this, and that's we want to be connected all the time with increasingly diverse missions, applications, and increasingly complex environments. And as a result, at this point, part of the electromagnetic spectrum that we use for communications is becoming increasingly crowded. You can think of it as becoming like our highways around our major cities. They're becoming increasingly crowded, and so everything is coming to a standstill or halt. So what can we do to begin to address that? Are there opportunities to create what I'll call a data superhighway? And one way of doing that is we can begin to move to higher and higher frequencies for our communication systems. And that's what I show in the plot here, which shows data rates, how much data we can move as a function of frequency. Today, we live in the lower left-hand corner of this plot. For example, the 5G communication systems of the smartphones that we all have today. If we can move up into the millimeter wave frequency domain, we can improve the data rates or the available bandwidth for communications by 1 to 2 orders of magnitude. In fact, the commercial world is starting to look at that in the lower millimeter wave frequency with millimeter wave 5G and possibly experimenting with 6G systems. Well, why not we move even higher in frequency to a part of the millimeter wave spectrum known as G-band with even another order of magnitude increase in frequency or data rates. And so that can open up a new opportunity for creating this new superhighway for moving our data and being increasingly communicating. Now, why can't we do this today? Here's some of the challenges. While there's been great advances in silicon technology, we can make really compact circuits. And here's an example, something done by Intel. It's a radio. It's a millimeter wave radio in a package. Each of those gold elements is an antenna element, and all the electronics fit on this system in a package. The problem with the silicon technology at these frequencies, that radio is incredibly inefficient, which basically means you're going to be draining your battery pretty quickly while you're communicating. There's a class of semiconductors called the 3-5 compound semiconductors, which have superior RF performance and can operate efficiently up at these millimeter wave frequencies. But these tend to not be very mature or dense electronics. So how can we get the best of both worlds? How can we get the compact RF integrated circuits that we can get with silicon technology and the high RF performance that we can get with these compound semiconductors? This is where the area of 3D heterogeneous integration comes in. And what I mean by heterogeneous integration is the mixing and matching of different semiconductor technologies and components into a single system in a package or a system in a chip. And by doing that in a 3D dimension, we can stack these chips on top of each other to create really compact, efficient systems. 3D HI happens to be one of the themes for the Microsystems Technology Office, and in fact, it's also a theme for ERI 2.0, which we heard a little bit about on the first day. In fact, as part of ERI 2.0, there's a program called NGMM, Next Generation Microelectronics Manufacturing, that is looking for innovations in 3D heterogeneous integration manufacturing. And another area, one of the programs that I have is a program called ELGAR, and it's particularly focused on, can we build the electronics to support these G-band arrays or these G-band radios for that high data rate communication systems. There's a lot of technical challenges that we have to overcome, and we're looking for innovative ideas of how we can create these very compact circuits, how we integrate these 3D integrate these dissimilar materials, and how we can make these circuits as efficient as possible so we can increase the utility or data rates or lifetime of our radios. One particular challenge is the compaction. These antenna elements, these gold antenna elements, they're less than a millimeter square at these frequencies. So we have to fit all the electronics into a very small area. To put that a little bit into perspective, that little radio would fit on Abraham Lincoln's nose on your penny. So we're really looking to go to really dense, compact electronics and very high efficiency electronics. And we're looking at 3D heterogeneous integration as a path to do that. So if you would like to learn more, or if you have some innovative ideas in this area, why don't you meet me at lunchtime or at one of the breaks, and we can have a nice discussion. Thank you for your attention.